It is me from the future, and I have had a night to sleep on it and think about this problem for day 8. And what I have realized is that there's not actually that many combinations, right? Like it's just what 7 factorial, which I should know, but let's see, product 1 to 7, that many. So like we can definitely just chug through 5040 options and find out which one's right. Um, Although it might be more fun to write some sort of solver that actually like works out which ones are right. Um, that sounds really hard, and my head is a little bit empty, and so I think we'll just do it the brute force way. Because I don't really see why that wouldn't work. But before we get into that, I think I want to refactor a little bit. As much as I was like obsessed with being able to do this like type safe thing with the tuples, I think it's time to make these just lists. Because I'm gonna go crazy even just thinking about how to apply a mapping with the tuple way seemed bad. So instead of doing that, I am going to make this a list of bools, and this is going to just be that. Easy. And this is going to be that, and that, and that, right? I need an equal sign. Like, this just makes things a lot easier. So I think this is the right thing to do. So solve A still works. Let's make sure. Um, what is it? AOC run A? No. Because of all this. So let's change these to that, and that. Is that enough? 479? Was that the right answer? That was the right answer. Okay, so we're doing good. We're gonna change this too. So this is gonna be list of int. We're not gonna use this possible mappings thing anymore. And instead, what we're going to do is we'll generate all the possible mappings, and then we can evaluate those mappings to see whether they produce valid digits, and we'll just find the one where all of the things produce valid digits, and that will be the answer. So, and it looks like we've even already um, got everything set up to, like, all we need to do is implement the solve mapping function, and I think that will get us all the way there. So that will return a mapping. So the other thing I want to be able to do is um, know if a digit is actually a digit or not. So let's do like is digit, and then all of these will be true, and anything else will be false. So this will take a signal combination and give us a Boolean as to whether it produced a valid digit or not. Okay. Now we do need to figure out how to apply a mapping. So I'm just going to move this down here. So let's think about that. So, I guess we could think of mappings the other way because we're just generating them all and it doesn't matter. So what it's actually going to be is, so let's do mapping combo. It's going to be map and then combo at mapping. I think that will give us, like, this is the other way than I was thinking of mappings being before, but I think it doesn't really matter because if we just do all the possible combinations, then yeah. Okay. So in this one, we're given a bunch of signal combinations, and we need to see if a mapping works for all of those signal combinations. So let's break this out into a is correct mapping, and this will take a mapping and a list of signal combinations and return a bool. Correct mapping. Mapping combos all is digit apply mapping combos. I think that's right. And you want me to reduce. Great. Okay, that's easy. So now we just need to let's literally do like all possible mappings. And that's just going to be a list of mapping. Possible mappings equals undefined. And I think we'll do that next, because this will, for each possible mapping, find one that is correct. So combo. Yeah, I guess it's just going to be the first one where filter we don't need to do that. We just need to do is correct mapping. Yeah, is correct mapping. We'll use a section. Is correct mapping combo. That's what the linter always wants me to do. Yeah. Okay, this is like too easy. So all we have to do now is generate all of the mappings. And I feel like there's a Haskell way to like get all the, I think there's a standard library function to get all the shufflings of a list or all the permutations. Let's see. I guess it would be just that, which might be difficult. Reverse cycle. Permutations. Oh, that's right. It would be that, of course. Permutations. Is that right? I think that is equals permutations of 0 to 6. And is that it? I think that might be it. So, I mean, unless we've done something wrong, which is very possible. Let's try it out. So test B, 61229. Okay, it took a little while, but we got the answer. So this was so much easier than I was making it out to be, at least doing it the brute forcey way, which isn't too bad. Let's see, how long does that take? No. Oh, it deletes it when it's done. How long does that take? 2 seconds? It's fine. Yeah, that's fine. So this turned out to be like a really straightforward way. We just got all of the possible ways that you could map this. So let's see. All possible mappings. It's just a list of all however many thousand. I've already forgotten. Product 1 to 7. All 5,000 ways that you can order that, which is not that many. It's interesting that they don't seem to be in a particularly deterministic order. I wonder what this does. Okay, does something complicated. We won't look at that. So that's cool. We have the permutations, and then basically for each of those, we just find the one that is a correct mapping for that combination. And we'd already done the work yesterday to actually map that onto the answer part and turn it into a decimal. So yeah, that was what we had to do. Pretty straightforward. So hope you enjoyed, and I'll see you tomorrow.